What is this, Pedro?
Hey everybody, this is the Adafruit Show and Tell. This is the best place to show off your awesome DIY projects, whether it be like PCBs or projects like with 3D printing or wearables, or if you're taking us on a tour of your awesome workspace. Everything is game. We'll be posting the link on discord.gg/adafruit to get the link, and you can join in and show off your awesome project. We're going to take about 30 minutes to check out everybody's project. Take about a minute or two to show off your stuff, and just give us the elevator pitch of what you're working on. We're going to go ahead and start off with Stefan. Let's go ahead and see. Oh, actually, no. Sorry. Everything got all mixed up in order. Let's go ahead and start off with John.
Okay. Hey,
Hey, John.
Hey, guys. How's it going?
Hey, not too bad. What's going on? What are you here to show off today?
So I'm going to be showing tomorrow a project on my show, on the workshop show, where I'm going to look at these really cool little inductive powered LEDs. So here I've got a little setup with a welding minifig, little Lego guy.
Awesome.
You can see I've got some nice lighting here, and the cool thing is that no batteries required and no wiring. So this is just kind of free-floating LEDs, and I've just set them on my little welder guy's workbench there, and you can see if I cover up my light source there a bit, you can see a little better. And so I'm going to show the little sort of display stand that I've built here. We'll be working on that to hide the inductive coils that are used to give us lighting in any orientation. So pretty much anywhere you go, you're going to get these to light up. And I also have a tabletop miniature that my friend Brian lent me. That's a familiar one to friends of Mandalorian, and
I was gonna say
a couple of little red ones in the thrusters there. So we'll be playing around with some lighting for models, which these things are incredible for that. Really cool innovation to be able to light up small stuff without wiring anything and without worrying about batteries. So
how freaking cool!
Tomorrow.
We got to figure out ways to like incorporate this into some sort of interior design in the house somewhere. This is so freaking cool. So you have like two of them, right? One that's like vertical and one that's underneath.
Yeah, and it's actually not necessarily required depending on the orientation of things, but since I wanted to have some stuff planar to the ground and some other stuff planar to the wall, it's helpful in that case to use a couple of coils, but you could also find creative ways to be sort of diagonal, and especially with these larger coils, you can see here they're happy to light at a lot of angles and at pretty great distances as you move around. So there's a smaller one, I haven't played around with it yet, that's this little coil here. The coil I'm using in here is about 8-inch diameter. These little ones are lower voltage and smaller range, but also a lot tinier, so convenient for different types of little models that you'll build.
How cool! So this will be on the
tomorrow show.
Workshop show on tomorrow. Yeah, Thursday at 4 o'clock Eastern. So come on by and we'll play around with models.
Yay! Thanks so much, JP.
Thanks, JP.
See you guys.
All right, next up, we're going to talk with Brian from DigiKey. All right, Brian, here we go.
Hey, Brian.
Hello.
Howdy. Hey, guys.
My bad here. Let me add your screen here, Brian. There we go.
So you got some cool sensor stuff to show off?
Right. Let's see if I can learn how to navigate. I can't see that at the same time because this is a...
Oh, yes.
Is it zooming in for you?
It is. It's coming in clearly.
Excellent. All right. So this is a water sensor. This has saved me, I'm not sure how much money.
I think I could tell you how much it would have saved us, about $80,000 in kitchen repairs.
We had a main drain in our basement back up.
Oh, no.
Because of tree roots.
Oh, jeez.
And when you find 2 inches of questionable water in your basement.
Yeah.
I was suddenly motivated to create a water sensor that I wanted to make it as simple as possible and draw as little power as possible so that you could battery power it and pretty much forget about it. So the basic elements here are just a dirt cheap, simple MOSFET. This is a 2N7000, a 10 meg pull down to keep the gate low And for those unfamiliar with MOSFETs, it's just going to act like an on-off switch. And because it doesn't really draw anything when it's sitting in one state or the other, as far as like here, when it's pulled low, it draws next to nothing. I can't even measure it with a 6-digit bench DMM. The noise in the room is the same whether you hook it up or not. So
that's awesome.
So we've got a battery here, got a 9-volt battery, and then this is your terminal here that you just hook up your 2 wires and run that wherever you anticipate water misbehaving.
Okay.
I found out that you can kill a MOSFET pretty easy by exposing the gate to a little bit of static.
Oh.
Once it's in place, you're pretty solid, but something as simple as adding a 1 nanofarad capacitor to the gate slowed that rise time enough that I have yet to kill one just by adding that. It's not your normal transient voltage suppressor, but it works.
Nice.
By using a pulsing buzzer, that's just human interaction stuff, that a constant tone doesn't grab your attention nearly like something that turns off and on, especially if you've been to McDonald's or anywhere that, hey, the machine's yelling at you.
Yeah.
Then I took it one more notch, and this is an elective thing. Normally you just pull the battery if you've got a 9-volt and it's just hanging there. But my wife didn't like that idea. She was always afraid she was going to wreck something. So I put it in a case and then put a simple alternating, I think you can see the part down here, just a simple push button switch that you click it once, it's off, click it again, it's on, and it's just switching back and forth. So, well, I shouldn't say off and on, but it takes the power away from the buzzer, runs it through a self-flashing LED, which these things come in really handy. And then it's reminding you, hey, you turned it off, dude. You're not protected. So you click it again, you're back in action.
That's awesome. I love it.
By using a lithium battery, you're good for, their shelf life is like 10 years.
Wow.
They're expensive, but compared to water in the wrong spot.
Dude, it's a fraction. Yeah, I love that you have everything laid out here so people can just rewatch the video. And I think those are all the product ID numbers on DigiKey, right?
Correct. Yep. And
awesome. Yeah. So
I could always share the URL. We're using Schemit, the built-in diagramming tool that we have on our site. So.
Oh, awesome. Yeah. No, beautiful plug for that. Yeah.
And
awesome.
If you want, I can show you a quick picture of it in action.
Oh, yeah.
Please do. I'll bring it in.
Let's see. Share screen. Sorry, my first time.
Oh, sorry. You're good.
Here we go.
If it pops up somewhere, there it is.
So here, this is one that I didn't. Let me see if I can zoom in here. So I just debugged that thing.
Nice.
Nice.
It works.
That one I ran a Zener across instead for a transient voltage suppressor, and that one sits underneath our sink, as you can see. And the second pair of wires coming off, that actually goes underneath our dishwasher, and that saved us twice.
Wow.
We've got 2 bare wires snaked around underneath it. And so we had a leak a couple times. Otherwise, you would only find out
after
having copious amounts of water leak through the floor and into the basement. So
yes, dude, I want to build 6 of these for each bathroom and have them just everywhere in the back, because we were
noise you never want to hear. But
no, you want to hear just in case. The earlier, the better.
Yep, it's like insurance. You're buying something that
I wonder if our rate would go down if we told them we had these. Excellent project, Brian. This is fantastic.
Excellent.
Cannot recommend people go check this out enough. Holy crap. This is great. Thank you so much.
Thanks, Brian.
Take care, guys.
Thanks.
All right, next up, we're going to check in with Melissa. All right, Melissa.
Hey, Melissa.
Hello. Hi.
Hey.
So I have this little gadget that I'm working on here. It's just a little terminal thing with a little 7-inch LCD attached to a Raspberry Pi. And I have it running a little animated GIF player here. And I have it so now if I go ahead and I turn this little knob on the back here that I have, I can get it to kind of play, or I can go backwards if I want to.
Nice.
And then I can click it, and I can go to like the next one, and I click it again, and it'll go to the next one here. I only have like 3 on here, so that'll go back to the original
choices.
one.
All caps.
So,
Yeah.
anyway, so I'm writing a guide on this right now, and that should be out either later this week or next week. And there's actually going to be another way I'm going to be doing it, but it'll be the same sort of thing.
Awesome.
Excellent.
And this is the code you already committed to GitHub, I believe. So people.
No, I haven't yet.
Oh, okay. Soon. Coming soon.
Yep.
Sneak peek.
Awesome.
Excellent progress. Thanks, Melissa.
Yeah. Thank you.
All right. Next up, we're going to check in with Scott. All right, Scott.
Hey.
And Scott's screen.
Can you hear me?
Ooh.
Yeah.
Yes, we can hear you.
We can see your pretty PCB. This is awesome.
Yeah, I like how you were speaking from experience with water damage.
Oh my gosh.
We
don't
saw a neighbor go
remind
through
me.
that, and it's just like really rough.
It's always sad. Yeah. Just walking around, like all of these are like vacation rentals, and they don't notice. And we have to call their management company and be like, dude, your roof's leaking. I see your water heater thingy is like for weeks now. But yeah, that is again awesome plug for DigiKeys. All the products you can do to build your own.
100%. Yeah. So what I've been working on is I'm diving into the Raspberry Pi, not the Pico, not the RP2040, but like what people think of when they think of Raspberry Pi. I've been doing so what I'm trying to do is ultimately I want to bring CircuitPython bare metal to the Raspberry Pi 4. So that it will act like CircuitPython, but particularly have the ability to do display I/O on HDMI. And it will simplify it a bunch too, because it will just act like CircuitPython still. So I've been trying to learn my way around the Cortex A series chip, like CPUs on these chips. They're meant for OS Linux class stuff, so they're a lot more complicated. And one thing that I wanted to be able to attach a debugger to it, and there's no Raspberry Pi boards that I know of where they just have a plug for it. But luckily on the 40-pin header, they've broken out the pins that you need. So I whipped up this board and I sent it out to Osh Park yesterday. And basically what it is it's got it wires up the debug headers. That's the big thing in the middle, and the smaller thing on the left-hand side. Those are just like 2 form factors for the same plug. It's got 4 LEDs at the bottom, so that if you're doing debugging by LED, you can have LEDs that you can blink. On the top left side is just a header that you can use like a USB to serial converter on. So that'll get you your serial output. That's the default. And then because I had the room and the I2C pins were right there, I threw a STEMMA QT on there as well.
Sweet.
So, I'm a software person, so I don't really like having like jumper wires everywhere. So I kind of like running PCBs like this, doing PCBs like this, just to make it like more tidy,
so you can unplug it and plug it back in, or like switch stuff around. It's super handy.
Yeah, so I'm excited to get that. Right now I have all the wires going everywhere. But yeah, if folks have experience in Raspberry Pi bare metal, feel free to ping me. It doesn't work yet, so I can always use an extra set of eyes.
Awesome. All right, cool. Sneak peek coming soon. I think you'll touch up a little bit on this on your stream on Friday.
Yep, that's the plan. Yeah, we'll continue working on it. Definitely made some good progress since the stream last week too.
Awesome. And I can't talk about it. I was gonna I can't wait to try that thing. Wait, I don't know if that's I don't know if we can talk about it soon. I'm like so hyped about all the stuff you guys are all working on.
Yeah, the BLE workflow stuff. Yeah.
Yes. All right, let's cut to someone else before I spill the beans.
Which is why I was like, maybe Noah and Pedro would be willing to help test it.
Oh my gosh.
So that'll be good.
Awesome. Thanks so much, Scott.
Cool.
Yeah, thank you.
All right, have a good one.
Bye. Okay, next up, we're going to jump in with some folks from the community. First up, we have Stefan.
Stefan, hey.
Hello.
Hey, hello. Hey.
So you got some cool cases to show off?
No cases yet. They are still in the making. So
okay.
at Home Assistant, we're working on a board, a custom board for Home Assistant. It's a Raspberry Pi carrier, Raspberry Pi compute module carrier board. That's basically what you can see here.
There we go.
Oh, I see it. It's up.
Yep, it's up here on your screen.
Hey, it looks cool.
Yeah, so I mean, it's quite straightforward. We made it with KiCad, obviously, and it has an M.2 connector, so we can actually hook up NVMe. So we have really a lot of storage. Then we also put on this Zigbee module, which allows us to talk to devices. And furthermore, we also have PoE. So this device is actually running. It's hooked up to Ethernet.
Cool.
It's running, and it's actually controlling that bulb.
Hey, awesome.
So yeah, it's working, but you know, with hardware, if you want to get it out to people's hands, you need to test it, and you need to get it in volume, and production is expensive, and so on. So that's why we actually started a crowdfunding campaign on Crowd Supply. And so if you wanna get your hands on one of these at one point, go check it out. It's on home-assistant.io/amber, and you get redirected to crowdfunding, or just Crowd Supply, or just go to Crowd Supply. You should see it there.
Sweet.
Yeah, I think what is kind of cool also to show. I mean, Home Assistant is open source software, right? And we're a lot about kind of privacy first, and also open source hardware. So this will be open source as well. And so we're really trying to kind of making the full stack, basically, from like software down to hardware. And I think it's quite exciting.
Cool. Definitely post a link in the chat. Definitely check it out.
I will do. One thing which I think is cool for especially for hardware hackers, maybe if you want to dive into Zigbee. So the Zigbee module we have on here is from Silicon Labs, and it's a Cortex M33. The firmware, of course, is kind of, you know, it's from Silicon Labs, so we cannot do much with it. It's not open source. It's what we get from them, but it's a Cortex M33, so you can actually debug it. We left on the debug pin headers there, and we even hooked it up through SPI to the Compute Module 4. So yeah, I mean, it's kind of open to get hacked.
Awesome. Thanks so much, Stefan.
Thank you.
Welcome.
All right.
Bye.
Hey, cheers. Okay, next up, we're going to talk with Liz.
Hey, Liz.
Hello.
Hey.
How's it going?
It's good.
All right.
So this is the project I'm working on with you guys. I brought it on last week. I had literally gotten the code working like 10 minutes before show and tell started. So basically what this is the RGB matrix stemma board hooked up to a FeatherSense. And so the FeatherSense microphone is taking in audio data, and then it's visualizing it into the LEDs using the Microlab library. And so I was playing around with different like color gradients this week. It's kind of hard to get show on webcam, but I think you can tell like when I'm talking, like you're getting more green happening. And so the gradient would kind of settle on, it's like more of like a kind of a brighter kind of rainbow, because it shows a little bit more contrast. And I think if I hold it up, you can kind of, I'll switch my camera. You can see it a little bit better too. See how it's like reacting and stuff. So I think there's been some updates to the library recently as well.
Literally yesterday. Right?
It's wild. So
cool.
Yeah, so something we're working on.
Cool. It's remind me of that. What was that mask? I forget what artist it was. It was Lady Gaga.
Yes.
Like that mask. Did the visualizer right on
the
there?
small, cute, pocketable version.
Yeah, that's so cool.
There you go.
Cool.
All right. Great progress, Liz.
Yeah.
Thank you.
So much.
All right. We'll talk to you later. Yep. All right. Next up, we're going to jump in and chat with Mark Gambler.
Hey, Mark.
Hey, Mark. And Mark Screen.
Yeah.
Oh,
hey.
So I know people like seeing works in progress, and it's really
Yes.
good because in Discord right now we're just talking about who started as software hardware. I definitely started as a software developer. I always was interested in hardware, but CircuitPython really got me into the whole world a lot more. And so this is now my design for an idea that came out of Show and Tell, actually, of a smaller version in some ways of the Funhouse. And this is the first board I've ever designed with an actual microcontroller on it. So there was some discussion. I have to give credit to Doctor in Discord. He gave me a lot of good ideas on what features he'd like to see in this type of board. But to be able to have a Wi-Fi enabled board just anywhere in your house and quickly plug in sensors through STEMMA QT and report it to Adafruit IO.
Yeah.
So there's lots of boards that you can use for that, but I thought, well, can I add in some features? Like, what would you want in sort of an all-in-one board so you're not having to combine a few things? So I don't actually have a lot of 3D parts, but there's a buzzer, LEDs, well, a couple of the switches like reset and boot, but just a general purpose switch as well. Just so then you could take one of these things, plug in whatever sensor you want, or you chain several of them together, and plug it in wherever in your house you need. Right now, it is only USB powered, though. That's the only downside.
I think that's good.
Yeah.
Which micro is this based off? The ESP?
This will be the ESP32 S2, okay. The same one that's in the Funhouse and the MagTag. It was actually one of the first ports that I did port-specific code on CircuitPython for, so I was a little bit more familiar with that and had read the 600-page manual for.
Oh, geez.
Yeah, that's another fun lesson I learned in all this is the length of some of these microcontroller manuals.
Yeah, it's crazy. No, this is excellent progress so far. I think attaching a water sensor, I think, through the stemma,
yes,
it's definitely going to be a goal.
When I bought my house, the basement had just been redone because of the hot water tank going. So it hasn't been my problem, but I've owned my house for a while now, so I should probably put one down there.
You don't want it to be your problem. This is a good insurance policy right here.
Yes.
That's what you're really building.
Can imagine that. Okay,
yeah,
thanks a lot.
He's come by next time with some more progress. This is great.
Hopefully I'll have a manufactured board soon.
Yeah.
Oh,
all right.
Can't wait.
Thanks, Mark.
Thanks.
Check you next time.
All right, next up, Gustav.
Gustav. Oh, sorry. Sorry, Mark. We'll come with you in a little bit later. Gustav right here. When people jump out, like I think it moves around.
I didn't recognize myself there for a second.
Oh, yes. My mistake.
Hi, so I was on Show and Tell like a month ago, and I showed off, I'd taken a Circuit Playground Bluefruit and turned it into remote control for my board game web app, and then communicating via web Bluetooth.
Okay.
So so the idea was you're going to pass that around, but then I figured I wanted to run wires so that every player could have a button where they're sitting. So I'll show that. I have to move my thing around a little bit. Let's see if this is visible.
Yep.
Right. So the first thing you'll probably notice is that I have baby bells here.
Now I'm hungry.
Yeah, no. Baby bells are amazing capacitive touch buttons because I can pick them up by the red piece and it's not going to detect the touch. But if I touch the cheese, then it's activated. So I'm just going to activate the game timer here. So the idea is simple. When the blue player is done, he just touches the cheese, and it goes over to the green player, Lady, who can then touch his cheese, and that's simple enough. But my game timer have kind of a need for two buttons. One button for ending your turn, and another button for passing the round. So how would I do that with a capacitive touch? Well, I just programmed it so that if I
hold it down.
Next up, Letty.
So that if I just press and hold for like 2 seconds, I have a little timer thing so that it figures out that, oh, that was a long touch. And I guess you could do similar things with like double tap and whatever you want, but I just needed 2 buttons from one capacitive touch sensor. So so that's that.
Awesome. And then when the game's done, I guess the winner gets to eat all the cheese.
I love that. That would definitely be the prize.
I think that's the prize. Yeah.
The thing that I'm a little bit confused about is if I run it off battery power, so it's not connected to like a sink or ground or anything, the capacitive touch seems to not work so well unless I run a wire from ground to one of the ground ports on the thing. So if someone can explain why that is,
maybe somebody in Discord.
Chat me in Discord because I'm not why.
Cool. No. Thanks so much, Gustav.
Great progress, Gustav.
Bye, everybody.
Bye.
And now I need some cheese.
Okay, not before Mark Hughes.
Hey, Mark.
Hello, Mark.
Hey, guys. How you doing today?
Hey, all right. How are you doing?
Good. The amount of attention-seeking behavior I've been exhibiting on the other side of the StreamYard has just been insane. So thank you for taking me. Hey, I run a site for some sponsors called Teach Me PCB. So all you people out there who are looking at these PCBs and you want to learn how to make one yourself, we're going to teach you. And this year's project is a keyboard based off of some of JP's work. So this is the one, you know, you can get off of Pimaroni. We're making our own. This will be the demo. It just came in about 30 minutes ago. I obviously don't have time to solder it and populate it, but this is just the demo. You get to design your own. And we're giving away a lot of the parts you need. 25 lucky participants are going to get everything they need. This is nothing. This is a real leader I was using for attention. So visit Teach Me PCB, sign up. We're going to start October 11th. You only need to devote about 2 to 3 hours per week. I've got hooks into manufacturers. The same people that make the Osh Park boards are making ours. DigiKey sponsored. Last year we were able to give away a nice Keysight oscilloscope, Altium licenses, all sorts of fun stuff. 100% free. We're not selling your information or anything. The only gig is that you have to look at the sponsor logos whenever you log onto the site. That's the extent of the advertising.
How cool. I like how you had everything on like a bandolier. It's like, yeah, dude. That is like the modern day like Rambo, dude. That's so awesome.
That's what I was going for, Rambo.
Yeah, that's so cool. It's a good costume, I think, but only like certain people would know what that is. How cool! Thanks so much for the plug.
I'm trying to put it all over LinkedIn. If you know any aspiring engineers in the pipeline, that's really who we're targeting. But anybody who is motivated, if you can breadboard, I'm trying to provide you enough information to complete the course. Last year we had like 600 engineers sign up. We even had like a 10th grader we did a competition. He came in second. A 10th grader. Cool. Yeah, he's going to have my job if he ever figures out what my job is.
Oh, no. That's not bad.
So thank you so much for your time, gentlemen. And that's my attention-seeking behavior.
All right, Mark. Have a good one. Thank you so much.
Bye, guys.
All right, everybody. Thank you so much for coming in. We ended just in time. Don't leave yet because in just about 2 minutes, we'll have Lamar and Phil, Mr. Lydiata, will come on and do a full hour of open source hardware.
All that and all the cool new things coming out. So stay tuned.
All right, folks. That's it. We'll see you guys next week. Bye.